Well, welcome back everybody. You may remember from the last video I got the clock ticking again, but one viewer pointed out that the escapement seemed to be worn, in that the pendulum wasn't moving very well. In fact, as the pendulum reached the tick where the escape wheel left the pallet, there was no extra movement. It would then start to go the other way until the top, and again it would stop at that point. So it would go backwards and forward, you get the tick and the top, but there was no additional swing. It's called supplementary arc, and so normally when you get to the tick, you allow the pendulum should go a little bit further and then back to the top and a little bit further, so that there's enough energy in there to cater for any movement of the floor beneath the clock, which might be enough to stop the clock. So supplementary arc, and that is because the pendulum escapement is actually worn and not providing enough energy to the pendulum. Right, let's see if I can just draw a quick diagram to show you where the problem is. If we just draw, great pen this is, they're the two pallet arm faces. And if the pallet arm rotates around that point there, this edge goes round like that. So there's our pallet arm, and if we assume that the escape wheel is rotating counterclockwise. Now if we imagine this here is our escape wheel tooth, it hits the pallet arm on this side here, and as the pallet arm rocks, it slides along the hardened steel edge to which is the tip, and then it flies across to the other side and hits the pallet arm there. And then as the pallet arm rotates the other way, the tooth slides down the hardened edge there to get to the bottom, and then it rotates round there. And so what you've got going on there, you've got the internal drop of the escape wheel, which is essentially this space here, and then you've got external drop, and it goes all the way around, and that's external. So as the clock wears, you have wear in two parts. You have wear on the escape wheel tooth, and that's pretty even. You can't really see it on the teeth, but on the pallet arm you see the faces, as you'll see from the pictures, have worn, and so the internal drop has got longer because of the wear on the hardened edge there, and also the external drop has also got larger because of the wear on this side, and that means that you're getting reduced energy given to the pendulum. So what traditionally, and I think it still happens now, is you add some hardened steel. You remove the hardened steel of the pallet faces there, and you put in, exaggerated this, but essentially a new bit of steel on that side, and if necessary you can put some on that side if both sides are worn. So the added thickness now means you've got reduced internal and external drop, and therefore you get your power back. On the external drop, sorry, it's because you've got the extra thickness there, and the internal drop, often you can make the face on this side extend beyond the pointed edge, and so essentially when the tooth comes round, rather than dropping there, it actually drops there, so the internal drop is actually reduced because of that extra edge. So that's what we've got to do, is to replace these two, and I think you'll see from the pictures that both sides are quite well worn, so we will actually do both sides, but sometimes you can just do this side only, and that would actually reduce both the internal and the external drop. So I hope that makes some sense, and don't worry guys, I'll be going back to art school once this video is finished. The pallet faces are hardened steel pieces that were soft soldered onto the pallet, so I will desolder those and put some new pieces on. Traditionally they used a clock mainspring, and in fact that's what I'm going to use, as it's a hardened blue steel. Now it is hard, and that means that it's difficult to cut, being so hard, and so we're going to anneal it, which will make the steel more workable. And so, as you remember from your metalwork classes, to anneal something you heat it till it gets to cherry red, and then you let it cool slowly, and that will make the steel more malleable. Then we'll be able to cut it to size and fit it to the pallet. So I'll keep the end piece here. Starting to go a slow pink colour. It's taken a while to get pink. I maybe should have cut the piece off first, but we'll carry on. Yeah, it's starting to glow red now. It's nice and pink in the very end now. Right, and now we'll let that cool slowly. So I'll put that to one side to cool down. Make sure I don't touch it. While that's cooling down, we can take the old pieces of steel from the pallet. They're soft soldered on, so we're going to heat this up now, and I'll use a little blow lamp here to do that. So I'll put that in a vise, heat that up, and then I should be able to brush off the old bit of so I'll heat that up, and then I should be able to brush off the old piece of steel. Now the pallet arm is attached to the crutch, and it's actually soft soldered there, so I don't want the heat at the end of the pallet to get to that and melt that. So I shall tie a bit of cloth around there, damp cloth, to keep the heat away from that area there. Put this into a vise, like that. So there's the first pallet face that I'm going to desolder. To do that. Right. Pallet force. I could have used the soldering iron, but I think this will give a more even, steady heat. And I don't want to overheat it. I just want enough to melt the solder and then to be able to brush the solder off. And I think I'll use a toothbrush just to do that. Well, that wasn't very successful. I think I'll have to get the blowtorch on it. There it goes. One side up. Where did it go? side. Okay. There we go, that's the two plates off. And that's the spring cooled down, so I can now cut the two pieces off, ready to put on to there. I'll come back when I've cut those two pieces out. Right, I've got the two pallet faces cut to size, and now I'm going to temper them to get them back to a hard condition. So to temper, I'm going to heat them up to a cherry red and then cool them straight away into some cold water, and that should make the pieces of steel very hard again. So I have cleaned two pieces, and what I'm going to do, I've made a little bit of wire catch basket here, and I'm going to put them in there. Two in there, so I can heat those up. Let's come out. Heat them up in there to cherry red, and then dump them in the water. It's a small one, very red. There we go. Get them nice and chewy red. Right, that's some really cherry red, and then put them into cold water as quickly as possible. Steady. That's them in the water. Maybe cannot see, there's a bit of fire stain on them, so I'll have to clean them up again before we add solder to them. can see the fire stain on there. So I'll put them back on the file. And this is the first time I've actually done anything like this. And the fire stain, it's quite taken quite a bit of time to clean off. Apparently you can use soap. You can coat the piece of steel in just some household soap before you put it into the flame, and that apparently can reduce or prevent the fire stain. So maybe next time I'll try that. But it's not taking too long to just clean them up again. And before we solder, we have to make sure that these pieces of steel are very clean, because for solder to work properly with some flux, you need a very clean surface on both sides, otherwise it just won't take properly. Right, that's good. I'll just put that in some IPA alcohol to clean off. And the second the steel. This is a very, very fine file abrasive I have here, and the good thing is you can just slide it along and keep it flat, so we don't get any curved edges on the sides. If you use sandpaper or something, then you're going to have a wavy surface, and you don't want that. Right, I think that's now it's ready to solder these back onto the pallet arm. There we have the same issue again with the pallet arm where it is attached to the crutch with solder. I'm going to just keep it cool by wrapping a bit of cloth around it, wet cloth. Right, there is some solder on the surface from the previous thing, but I'm going to add a little bit extra anyway. So first of all, I'll put some flux . On the surface. And then I have some solder here. Cut a piece off. Lay it on the top there. Put another bit on. And then with a bit of heat underneath, we should be able to melt that solder onto that surface. Right, I'm going to try this again, because again, I don't want to get things too hot. I don't want the solder start to go black. So let's see if we can do it with this. Disaster last time, but we'll see. There we go. Let's see it now starting to stick to the middle. That's a nice surface of solder on the pallet arm. do the same with the piece of steel. I'm just going to give that a bit more of a clean with the file. Get it as clean as possible. Into the IPA alcohol to clean. Further clean. Right, this is the same trick now. Bit of flux. Not so much this time. Solder. Just See. Turn on. Yep. Fortunately, it didn't stick to the tweezers. So that'll go on there like that. And I'm going to have to hold it down while I heat up the underside. That position there. This will be fun. Okay, here goes. Maybe I should use the tweezers. That's it. Let's just wait for that to bond. Keep them very still while the solder melts and then hardens. That's one on. You can see where the solder's melted around the sides. I think that would be good. Now the other side. Same problem here. Is this clean enough? I'm going to give this one a little bit more of a clean as well before we put the solder on it. How does that look? Nice, put that in the IPR cup to clean. And go the same trick. Heat that up, apply some solder to it. Just a fraction, bit of flux, just allows the solder to spread across the whole surface. That's how it works. solder just lay on the top. Right, heat it up. I think because of the arm here, it's quite takes a while to heat up, so I'm going to use the blowtorch this time. But just be careful. Nice surface on that. Nice silver surface all the way across the top there is what we want. And now for the piece of steel which has been hardened and cleaned in the RPO alcohol. Surface. Get a solder. This is some of my dad's old solder when he was alive. He used to be a TV engineer and he left me reels of solder which I knew would come in handy one day. Right, heat this up. Nice silvered edge on that. Just going to go on here. Right, same problem. Well, same again with relish. Right, blow torch time. Lined up. Hold it there. I think that's stuck quite nicely. We'll see in a minute. Right, the first thing I'm going to do there, clean, is I'm going to clean that flux off, because flux is a very good corrosive, and we don't want to have problems with the flux causing things to corrode. So using a bit of IPA alcohol. Wash the flux off. It's a slight solder splash over the edge on one side. I can file that off. Right, I'll clean that up, and then I'll show you, and then we'll put it back in the movement and see what difference it's made. Here we have the new edge, the input pallet. And the output pallet. Not a bad job if I say so myself. Right, we can now try this back in the movement. Well, this video has broken new ground for me. Refacing pallets is a new skill I have developed, and it went very well, I think. Just took my time, and the steel soldered very nicely to the pallet arms, and now we have a clock that's ticking away. There certainly seems to be a bit more push to the pendulum, and there's definitely a bit of supplementary arc where there's a bit more of pendulum movement at the tick and at the top. So overall, really happy with this result, and so looking forward to the next video. Thanks very much for joining me. Please do subscribe if you haven't already. It's the case that only 10% of my viewers have subscribed. So I'm now breaking new ground with new skills being developed, and I've got some exciting clocks coming up as well, which again is going to push my capabilities even further. So do subscribe, and I look forward to seeing you all in the next one. So bye for now.